In today's assignment, I hit you with a bunch of conversions to do at once. This would not be something you would be asked to do on a test. You would be given very clear, simple instructions to calculate a density. However, conversions in the real world are very important. NASA lost an entire multi-million-dollar probe, $200 million, literally lost, because of a metric conversion error that had the thrusters operating at the wrong level because one part of NASA used metric and the other part still used imperial. And this is why in Canada we still have a mixed measurement system, because the United States still won't switch over to metric. So we still... Alrighty, let's see how we can convert what I know you've run into. First of all, I've drawn a 1 meter cubed box. And you know this little virtual fish tank? That was virtual reality back when I started teaching. And drawing a three-dimensional fish tank was something I taught Mr. Neal when he was in my class as a grade 9 student many years ago. And somewhere in the depths of my files, I have Mr. Neal's fish tank. So you can tell him from me that I recall his work, and I'm glad to see with Oculus Rift and all that virtual reality has improved a lot since he was there. So, what did you find when you looked up glass? You were quite likely to have stumbled across a value something like this, 2,600 kilograms per cubic meter. And you're like, oh my God, Mr. Colati already gave us feet and millimeters in the glass. Now I've got this. Can't we get these units together? Well, density in kilograms per cubic meter is quite common in industry because, let's face it, people don't order sugar cube size pieces of most things. They tend to come in much larger quantities. Engineers that build a dam may be talking in cubic kilometers of water. So there's actually a real simple conversion. I could give it to you, but it's meaningless. I want to show you how it works so you can regenerate or make your own conversions. And at that point, you go like, hey, I don't need help. I can do this myself. So let's first of all draw it properly like that. All right, we've drawn it so we can see those units. And our problem is we got the K that's in front of the grams. Well, what does K mean? That's like saying, hey, I got 26 grand. And you go, oh, $26,000. You do this all the time. If I said to you, that guy's boat cost 2,600 grand, you would go, that's $2,600,000. So to get rid of the K, all you do is change it to what it actually means. It means $1,000. 1,000. So trust me, when you say, I can't convert kilograms to grams, I've not met a kid that if I say, hey, what's 21 grand? They go, $21,000. So you know how to do that conversion. Have a little faith in yourself. Now, what do we do with the meters? Well, I've got to go to a separate screen here. What are we going to do with these meters? We got to get rid of them to centimeters. And here lies the number one mistake students make. They write this. Okay? But that's not a correct conversion because cubic centimeters isn't a single centimeter. It's 3 separate measurements, length times width times depth. So 1 meter horizontally is 100 centimeters. Then there's 100 centimeters vertically and 100 centimeters in depth. That's 100 3 times in a row. So that is 1, 2, 3, 4, 5, 6 zeros I'm counting in here. So you now have a factor of 1 million cubic centimeters in a cubic meter. Now I've drawn a very absolutely god-awful little cube in here. A cubic centimeter is about the size of a sugar cube. And a cubic meter is a box that you could just get your arms around one side. You remember, if you recall, there was a building called a school we used to go to once, and I stood behind a big black desk called a podium. And that podium, if you cut it in half, because it was rectangular, and put it together as a cube, that would be a little bit larger than a cubic meter. So now I want you to think of this. Who is correct? If your friend says a cubic meter is the same as 100 cubic centimeters, you've just said a box as big as the desk in the classroom could be completely filled with 100 sugar cubes. So that is one of the ways you can use your visual memory to double check your math. Whenever you compute a volume in cubic centimeters, imagine that volume being filled with the same number of sugar cubes, and your brain will instantly tell you you've made an error, because this error here is not a small error. There are 2 zeros on this number. There are 4 zeros more on this one. That would be an error of 10,000 times, and your visual memory will instantly tell you you're wrong. Okay? So now we need to put these two together. I'm going to slide it over, and I'm going to rewrite what we've got here. Our original number, but now we got two conversions to do. Move the 3 up. Put that up there. Draw my line. Now we get to cancel zeros. This is really easy. So the 1 kilogram turned into 1,000 grams, and we now have 1,000,000 cubic centimeters. And so these conversions are going to do an awful lot of canceling. Move it up there. 1, 2, 3. 1, 2, 3, and we're left with only a divide by 1,000. Well, we can do that as well. Move it over there. 1, 2, and that 26 divided by 10? Why, that's 2.6 grams per cubic centimeter. So the only difference was that we bounced the decimal over 1, 2, 3 times. All this was the steps to get there. So if you're given density as kilograms per cubic meter, you convert it to grams per cubic centimeter by simply going boing, boing, boing with a decimal. And if you want to go the other way, just go boing, boing, boing back. That's one of the beauties of metric. The conversions get easy. Now, why wouldn't I just tell you, do this? Because you don't learn anything. You don't learn a bloody thing other than just doing it. I knew a girl in high school that sang opera. She sang it beautifully and with passion. The teacher in drama had her sing one of the opera pieces, and she had all the emotion and inflection in her voice at the right places, and we asked her what the song meant. And you know what her answer was? She didn't know because she didn't speak Italian. They had taught her the song word at a time. Now, did it matter? Not to us. But does she still do that for a career? Does she sing songs she doesn't actually know? Doesn't understand what's being said? And that's what happens if you don't learn how to do these conversions on your own. You're simply following procedures like a machine. Now, would I expect you to demonstrate these steps on a test? No way. Okay, not at all. And there's a much faster way of doing this as you get better. But I just want to show you it's within the capability. These metric conversions are not terribly hard, providing you're willing to try. Okay, so if you found the density of glass to be 2,600 kilograms per cubic meter, it is 2.6 grams per cubic centimeter, and you can use that value in your calculation for today's problem. Now, using this industry video to show you how tempered glass is made. First thing you notice about it is it had two really favorable properties. It was hard. It took him several more strikes to break it. And when it did break, it shattered into those tiny little peanuts that do not have a sharp edge. This was the difference between my left hand being intact and not intact. Okay, trust me, I know the difference between the two glasses. I got knocked through a glass wall as a teenager that was made out of regular glass, not tempered. And the regular glass, I came through looking like a voodoo doll. I was full of glass sticking through my body, one shard of it right through my left hand. I'm 56 and still dealing with that happening 40 years ago. So the tempered glass is cooked. And the cooking process changes its physical properties, not its chemical properties. In the slow-mo, guys, they recorded a segment of him jumping through tempered glass that had been pre-shattered and candy glass, simulated glass they used in movies. You can see the candy glass broke into shards, but the other glass broke up into peanuts. My own experience with running through glass is that the shards impale you and you don't keep traveling. So tempered glass has been a major safety feature in our world for quite a few decades.